I know, to my knowledge, this should be somewhat of a review from last year. It shouldn't be brand new. As always, I'm going to make sure that I do my best to make it as easy to understand for you as possible. We are going to have a stat box. All right, we all got the title? No, D1 and D2 are all about natural logarithms. Today we're going to kind of mostly focus on kind of the basics of natural logarithms, and then tomorrow we will focus on all those laws that we talked about on Monday and how those laws also apply to the natural logarithm. And they're both short sections. I could teach them in one day, but we're just kind of taking it slow to make sure you guys have enough time to ask your questions and whatnot. So, natural logarithms. To talk about natural logs, we have to think back about the natural exponential that we talked about last chapter. Does anyone remember what the natural exponential is? E. Exactly right. So, E is about 2.718 and so on and so on. But the thing that we can do is we can use E just like anything else. Like last chapter, we worked with E with our exponential functions where we had E raised to a power and we could do all the same things that we could do if I had a base of 2 or a base of 3. Well, we can actually do the logs with these as well. So if you think about it, if my function is E to the x power, then the inverse function would be log in base E to the x power. So this piece right here is not any different than what we've been doing so far. If I've got base E to the x, then the inverse would be log in base E. So just like what we did in sections A and B. It's the exact same, it's just that instead of numbers like 10, 2, 3, 5, and so on, it's E. This ends up being kind of a mouthful, log of base E, and since E is a natural number that occurs, we call it the natural log. So instead of writing log base E, we write ln. Those two things I circled mean the exact same thing. So the ln of x represents log base E of x, and we call that the natural logarithm of x. So ln x is our natural log. One thing that is kind of nice is that we can use all the same methods that we've been using with those other bases, we can still use with the natural logarithm. So if I take a look at this, if I have ln of e to the x, the ln and the e sort of cancel out, and all that's left over is x. This is the same thing as if I wrote log base e of e to the x. You know, we've talked about that before, that these pieces would cancel, but we had like 2's here or 10's here or what have you. It's the same thing, it's just we don't write log base e, we write ln. And it also works the other way, so if I have e raised to an exponent of ln, those cancel out, and all I would have left is x. Well, we can have that conversation about history another time. Okay, any questions about this stuff that's up here? All right, you're going to see something on the screen that you don't need to worry about, so don't forget about it. We are going to move on to examples. So we are going to find, without a calculator, ln of e to the third power. So find is kind of like another word for simplify or get an answer, and you should have a calculator that's capable of computing natural logs and has e in it as well. If you don't, you may want to find a different one. But we do want to do this without a calculator here. So one thing we just talked about was how the natural log and the e cancel each other out, right? So if they cancel each other out, what's left? 3. Done. Now, yes, we kind of take the basics and we add a little bit to it. So we're going to have another one with the exact same directions. It'll have a little bit more work to it, but it'll have the same idea. What we want to do is we want to cancel those out. We want to have ln and e to some power. So we're going to use that same method on the next one to see if we can find it without a calculator. So in this case, I have ln of 1 over the square root of e. So it's not like set up for me to do the canceling. I've got to do some work here. I'm going to have to play around with what's in that parenthesis until it says e to some power. The good thing is that we already learned how to do that last chapter. We've got to take this, first of all, this square root, and write that square root as a power. So remember that's like an invisible 2, so how would I write that square root as a power? 1/2. Not quite there, but I'm just taking it one step at a time because I need it not to be in the denominator. I need it just to be e to a power. All right, very good. When we bring that up, it's going to be e to the negative 1/2. Once we get this far, it's exactly where the previous example was. I've got ln of e, so those things cancel out, and the only thing left over is negative 1/2. So far, so good? So we're using some of the same methods that we've been doing before. It's just that instead of having a log and a base and a number, we've got natural log and e. All right, so the directions changed, but we're going to still use the same methods. So I want to simplify this. I've got the natural log of e times e to the eighth power. So same thing, if I can combine all that stuff that's in parentheses, so I just have e to a power, then the natural log will cancel that out, and it'll be a lot more simplified than it is right now. I feel like I heard someone say something. What do we got? Yes. So remember that we add those, because that's one of those properties that we had to memorize with our exponents from last chapter. It's not 1a. It's not multiplying. I cannot combine it more than that. So I've got the natural log of e to the 1 plus a. And then, yep, just as we wanted, the natural log and the e cancel each other out. So I end up with 1 plus a as being as simplified as I can go on that one. Now you're going to have a lot of different types with a lot of different properties. I do have more examples I could do of those 2 types. Do we need them, or are you feeling okay? You look like you're feeling okay, so hopefully that's true. So then there's one last type that we're going to talk about in the notes today. It's find x. It's like solving for x. In this case, I have the natural log of x equals 1. So we gotta get x by itself. Now you do not need to write this down. If we go back to whenever you took Algebra 1, if I had x plus 2 equals 5, what did you do to get x by itself? Subtract 2 to both sides, and x equaled 3. So I had to do like the opposite, or the inverse operation. The inverse of addition is subtraction, right? We're going to do the same thing on this problem, even though it's got natural log, but I have to do the inverse of the natural log. What's the inverse of our natural log? It's e. So that was something we wrote on like the first screen, so if you need to write that down, the inverse of natural log is e. And it goes both ways. The inverse of e is natural log, like they go together. So just like in that Algebra 1 example where we had to subtract 2 to both sides, we're going to apply e to both sides. So I'm going to raise both sides using e to that power. So I'll have e to the ln of x and e to the first power. So I'm just going to rewrite it to look like this. So that's my inverse operation. And just like we've already talked about, these will cancel each other out, so I just have x equals e to the first power. I do want you guys to take one more step, but are we okay so far? Yes. Yep, because there would be nothing for it to, there's no base then. So they cancel each other out, so it's just x. We wrote it on the first screen. We wrote this. Okay. Yeah.
So I tried to do it and I put that b as a natural log and I didn't switch it. So I ended up with b and power of
Yeah. Yeah, that would work. Absolutely. Because you're using the property we already know, Ben and Benny, we know that works, and it still works with natural log. So yeah, that works too. This was kind of like, did you guys look at yesterday's stuff? You know how yesterday we had to put log on both sides? Or you just didn't look at it? Well, then you gotta figure that out. But that was something you did yesterday, so I kind of wanted to show this way to connect. I just forgot to say it when I started showing it. But there are other methods, like Laura said, like switching it from a logarithmic equation to an exponential equation. That works too. The only last thing I do want you to do is approximate on your calculator. So x then is about 2.72 if we do 3 significant figures. So I know that there is also one other type of problem on your assignment that I didn't do an example of. So if you get that far and you're not understanding it, make sure you ask. I had several people be able to finish this assignment, so you really shouldn't have any problem getting there and asking, or you can ask tomorrow. The last thing in the stop box, how did I forget to move that around? We'll come back. What does ln mean? The natural log, or the inverse of e, it's the same as log base e. So whatever you need to do to make sure you remember what ln means, write it in your stat box so it's right there on the page for you.